Hi, this is Rob. I'm going to show you how to do the exercises that go along with the video lesson, Scientific Notation. Are you ready? Let's get started. For our first problem, we're asked what is the order of magnitude of these numbers? And we have 5.1 times 10 to the 4. And if you remember from the video, an easy way to know the order of magnitude of any number that's written in scientific notation is it's just the exponent. And so this is written in scientific notation. There's only one digit to the left of the decimal point. And so we know that the order of magnitude of 5.1 times 10 to the 4 is 4. And this is also written in scientific notation. Okay, just one digit here. And so the exponent of this is negative 10. So the order of magnitude of this number is negative 10. For question 2, we're asked to compare these numbers. Now we have 1 times 10 to the 8, and we're comparing it with 1 times 10 to the negative 8. So remember, if the exponent is negative, that means the number is really small. It's really close to 0. And if the exponent is positive, it means the number is really large. So 1 times 10 to the 8 is definitely greater than 1 times 10 to the negative 8. For problem 3, we're asked to compare these numbers. And we're given 8.5 times 10 to the 23 compared to 9.99 times 10 to the 21. And in scientific notation, if the exponent is different, then you can use that alone to tell you which number is greater. Because even though this first part here, 9.99, is greater than 8.5, it's being multiplied by a much smaller number. 10 to the 21 is much smaller than 10 to the 23. So 8.5 times 10 to the 23 is greater than 9.99 times 10 to the 21. For problem 4, we're asked to compare these numbers. We're given 1 times 10 to the 3 compared with 1,000. Now this one's tricky because they aren't both in the same form. This is scientific notation and this is the standard form, the regular form. So let's think about what this number really means. We have the number 1 multiplied by 10 to the power of 3. And what does 10 to the power of 3 mean? Well, it means 10 threes multiplied together. 10 times 10 times 10. And we can either do that directly, or we can start with a 1 and just move the decimal point 3 places. We have 1, and then we move the decimal. There, we don't see a decimal point, but there's always a decimal point after the 1's place. So we move it 1, 2, 3 times, and then we put zeros in those number places that we moved past. And so 1 times 10 to the 3 is the same as 1,000, and that's the number we're comparing it with. So 1 times 10 to the 3 equals 1,000. For problem 5, we're told convert this number into scientific notation. And we have 38,500,000. And we need to convert it to scientific notation. So we need to move the decimal point until there's only one digit to the left of it, and we'll count how many times we move it over, and then we'll use that information to write this number in scientific notation. So remember, even though we don't see a decimal point, it's right there to the right of the 1's place column. Then we have to move it 1, 2, 3, 4, 5, 6, 7 times to get the decimal point right here. So let's remember 7. We'll note 7 here so we remember that. Then we have 3.85 times, and then 10 to the power of how many times we moved the decimal point, 10 to the power of 7. So 38,500,000 is 3.85 times 10 to the 7. For problem 6, we're asked to convert this number into regular form. And we're given 8.1 times 10 to the 4. And we want to write that in regular form. And we can do that either by multiplying 10 fours together or by moving the decimal point. So we start out with 8.1, and then we move the decimal point 4 places to the right. Move it 1, 2, 3, 4. And then we have to put zeros in these number places that don't have any digits. and then we'll rewrite it so it's not messy like that. So we have 81000, and then remember to put commas every 3 spaces. Well, at least in America, there's some countries that do it differently than that. So follow whatever rules your country goes by. But for America and a lot of other countries, it's a comma every three digits to help us remember that this is 81,000. For problem 7, we need to convert this number into scientific notation, and we're given 0.000045. Just like before, we need to move the decimal point until there's only 1 digit to the left of it. Now, of course, there's a 0, but we want a digit other than 0. And so we need to move the decimal point until it's right here. We need to move it 1, 2, 3, 4, 5 spaces, but this time we moved the decimal point to the right because we were starting with a number that was less than 1. It's a number that's really close to 0, and so we're having to move the decimal point to the right instead of to the left like last time. And so that means that we're going to get a negative exponent. We moved it 5 places, but it was to the right, so it's going to be a negative 5. All right, so now we have 4.5 times 10 to the negative 5. For problem 8, we're asked to convert this number into regular form, and we're given 7.04 times 10 to the negative 3. So now, since this is a negative exponent, we're taking this number and multiplying it by like 1 over 10 3 times. We're dividing it by 10 3 times. So another way of thinking of that is that instead of moving the decimal point to the right, which would make this number larger, we need to move it to the left to make this number smaller. So we move it 1, 2, 3 places to the left, and then we would put zeros in here to fill in the missing number places, and then put the decimal point there, and then another 0 out here so we can notice the decimal point better. So we'll write this out clearly here. 0.00704 is 7.04 times 10 to the negative 3 in regular form. For problem 9, we're told to convert this number into scientific notation, and we're given this big number here. It's not real obvious how to say it, but let's see. This first group of 3 gets us up to thousands, these gets us up to millions, and then billions, and these get us up to trillions, so it's 6,250,000,000,000,000,000. This number here we need to convert into scientific notation. So to do it, we have to move the decimal point that you don't see, but it's right there. It's always to the right of the ones place. And we need to move it all the way over to here, so there's only 1 digit to the left of it. And these groups of 3 really come in handy here, because we can just count by 3s as to how many times we need to move it. So we need to move it 3, 6, 9, 12. So we need to move it 12 places to get it here. So we'll mark 12 right there. So let's write that out. 6.25 times 10 to the 12. For problem 10, we need to convert this number into regular form, and we're given 7 times 10 to the 7. So this is pretty straightforward. It's a positive exponent, so it means we'll be shifting the decimal point to the right to make this number larger. So we start out with 7, and there's a decimal point here that is invisible, of course, again. Then we move it 7, 1, 2, 3, 4, 5, 6, 7, and then we fill in zeros in these empty number places. We'll rewrite it without the movement lines there. So we have 7, 0, 0, 0, 0, 0, 0. And then we'll put in commas for the groups of 3, so it's easier to see that this is 70 million.